All right, so today's lesson is something new. So we're going to start off with this lesson, forget about what it's called or anything else like that, but let's just build some intuition. So it's a hot day, and Daisha wants to get ice cream, and she wants to get it now, okay? So what we're going to do is we're going to click on the closest ice cream cart. So I see that Daisha is right here. And so which is the cart that's closest to her, right? There's an orange, there's a pink, and there's a purple one. So it looks like Disha is closest to the orange one. Okay, so let's go ahead and click go. Boom, we're right? Check. We're gonna go ahead and do a couple more. So let's find where these other people are gonna go. So this is where the person is, right? So there's again three carts. Where should they go? The one that is closest, right? Is it this one? Is it this one? Oh, the closest to this one, right? All right. So we're gonna hit go and it's another one, right? Okay. So now we have a person that's standing here. Okay. They are not closest to the orange, it doesn't look like, right? That's pretty far. This is pretty far. It looks like they're closest to the purple here. Let's check that out. Good. Let's try another one. So this person's here, right? It's definitely not orange. So it looks like this person's going to be closest to our pink ice cream stand, and we're right. Let's try another one. Okay, this is ooh. Okay, let's see. So this over here, and over here. This looks like it's going to be a little bit far. It looks like it's going to be the purple one. Let's check that. Ooh, too far. So this one right here was the closest. Okay. So now this person's standing over here. Definitely not to the purple. Doesn't look like to the orange. Looks like to the pink. So go. And we're right. Let's try another one. I think you kind of get the idea, right? This person's going to be closest to this one. Try another one. This person's going to be closest to this cart, right? So this is what we're doing here is we're looking to see where the person is closest, right? So these right here, this purple, this orange, and this pink are called sites, okay? And what we're doing is we're looking to see where the person is closest to. So today's lesson is about something called a Voronoi diagram, okay? So Voronoi diagram, all that is basically you're looking for where if you have these right here are sites, okay? So sites are like the points. So like for example, if this was a hospital, right? If you're in this is called a cell. If you're in this cell or this region, then the closest hospital would be this one right here, or the closest ice cream cart would be that right there. If you are over here, right, the closest one would be this hospital, or ice cream cart, whatever you would like to call it. So we talked about what a cell is, right? So cell is like a region, so this is called a cell. It's a region in the diagram. A site is like the little dots, so if I call this site A, B, C, D, and E, those are all sites, right? It's a point in a cell. Edges are these right here. These are your edges. They're like also called boundaries, right? So there's something very particular about that line right there. You should notice that, right, between these 2 points, this one is the midpoint of it. And this line right here is called the perpendicular bisector. Okay, so this is from geometry. We'll talk a little bit about how to find that. And vertices are like this point right here, right? If I call this X, if I call this point Y, and I call this point Z, our X, Y, and Z are our vertices, right? It's a point on the edges, and it's the same distance from two or more sites, right? So this point right here, point X or vertex X, it is the same point, same distance from there to there, right? If I were to draw that a little bit better, okay, those are equidistant. Um, okay, so we did a little bit of vocabulary. We talked a little bit about what each of these mean, right? A vertex, again, is the intersection of edges. So that's X, Y, and Z are the vertices. Okay, I should have put this with this. All right, so we're going to go ahead and get started on what exactly a Voronoi diagram is. So an example is you're a city planner, you want to separate a region into smaller subdivisions or counties, and there's a capital city in each. So you want people to live in a county that's closest to the capital, right? So if somebody lives over here, they are not going to be closest to capital C, capital city C, they're going to be closest to capital city B, right? So depending on the region that you're in, um, that's going to be the capital city that is closest to you, or the hospital, the ice cream cart. We kind of talked a little bit about each. All right. So how do you find the equation of an edge between 2 points? So if you have point A and point B, right, and you have the line in between it, what we're doing is we're looking to find the gradient, which gradient, another word for gradient is the word slope. You could also call that average rate of change. So those are three words that all mean the same thing. So that's the first thing that you want to do is you want to find the slope of this line. The next thing you want to do is you want to find the midpoint, right? What is the point in the middle of those two? And then the next thing you want to do is find the gradient of the perpendicular bisector, right? So that is the negative reciprocal of the gradient that you got from here, and we're going to write it in the form y equals mx plus c. Okay, I'll call it mx2. So let's just back up real quick. In the most basic IB question, or the easiest one, they might ask you, okay, hey, you have a coordinate, okay, 3 comma 1. Let's just say 3, right? 3 comma 1. So that coordinate, right, is that closest to which site, or what site is that in? So since it's in this region right here, right, this region's capital city or ice cream cart or hospital is called D. So that point 3 comma 1 is going to be closest to D. Okay, so that's the most easiest question that IB could ask you. A mid-level question is they could say something to you like, okay, there is an edge that is missing, right? So to find the equation of this line right here, that completes your Voronoi diagram. They will never ask you to make a whole Voronoi diagram, so we're not going to spend our time doing that. All right, so here's an example of something that you might see on an IB exam. So you're planning the location of cell phone towers. You have 3 towers here. And one of the questions could be find the gradient of segment BC. So we are only looking at B and C. So you go x1, y1, right? So 4 comma 8, this point right here. And we're looking for the gradient between those 2 points. I can see visually that this is going to be a negative line, but let's just go ahead and do our formula. So y2 minus y1 over x2 minus x1. This is in your formula booklet. So y2 is 4 minus y1 is 8 over x2, which is 8 minus x1, which is 4. So 4 minus 8 is negative 4, divided by 8 minus 4 is 4. So this is equal to negative 1. So our gradient of segment BC is negative 1. Okay. Then it says find the equation of the line that completes the Voronoi diagram. So all you have to do is we want to find the midpoint, right? Which is this point right here. That's my dog, right? So the midpoint right here between those 2 points. So the midpoint, to find the midpoint, we do x1 plus x2 over 2 comma y1 plus y2 over 2, right? So let's go ahead and do that. So 8 plus 4, or 4 plus 8 divided by 2, comma, over here we also have a 4 and an 8, plus 8 divided by 2. And so this is going to give me 12 divided by 2, which is 6 comma 6 is going to be our midpoint. And visually I can see that, right? So this point right here is going to give me 6 comma 6. And now we just have to take the gradient that we got. So we have to find the perpendicular bisector. So perpendicular bisector. To do that, we say A, let's find the line, the slope that is perpendicular to this. So remember, perpendicular means we take this number right here, the -1, and we find the negative reciprocal of it, which is +1, right? Negative reciprocal, just to refresh your memory real quick, is the negative reciprocal of -5/2. You do the opposite, right? So this is negative, it now becomes positive, and you take this fraction and you flip it. So this becomes 2/5, right? So these two are negative reciprocals of each other. For the example that we just did, we have -1. If there's no number on the bottom, there's an imaginary 1. So again, if it's negative, it becomes positive. If it's positive, it becomes negative. So this one becomes +1/1, because if I flip it, it's still the same thing, which is equal to 1. So 1 is going to be our slope for the perpendicular line. So I have y equals mx plus b, or and as IB calls it, mx plus c. So our m is, we just figured out, is 1. So we have y equals 1x plus c. Now to find out what this c is, you're going to take this point that we have, which is 6, 6, and we're going to plug it in. So this is our x, this is our y. So let's go ahead and plug that in. 6 equals 1 times 6 plus c. So how do we find out c, right? 1 times 6 is 6. 6 equals 6 plus c, minus 6 from both sides, and you get c is equal to 0. Okay, so what is our equation of the perpendicular bisector? Let's call this part B. It's finding out what our c is. And then part C is putting it all together. So we have y equals, right? Our slope is 1. So 1x plus, and our c is 0. So we're going to plug that in. So we have y equals 1x, which is the same thing as just x. So now if I have y equals x, right, what does that mean? 5, 5, right? We have x comma y. So if x is 5, then y is 5. If x is 6, y is 6. If x is 7, y is 7, right? So if I were to start just plugging those points in, I should see that my third line, right, my third edge, my bad, is going to look something like this. So that's the equation of the line that completes the Voronoi diagram. And final answer is y equals x is going to be the equation of my line. All right, so last part of this question, complete the Voronoi diagram, right? So we kind of did that already. So this is our vertex, and we went like from here. If I said, okay, this is 4.5, 4.5, right? So our equation of our line is y equals x. You could do a plus c if you want, which is plus 0, but that's irrelevant, right? Because anything plus 0 is just itself. So this is going to be our equation of this line. So what can we say about the cell containing point C? And for that one, we can say that that all points in this cell are closest to C. Forgive my handwriting. All right. So the most basic question that IB would ask you is something like this. They would say to you, okay, if in this cell or region, right, there is a snowfall or rainfall of 3 centimeters in this cell, right, it is a estimated 9 centimeters, and in this cell it is 4 centimeters. So if you were in point A, right, if you were over here, which is the centimeter that you would get, like estimate the amount of snowfall or rainfall. So so point A is in this cell right here, right? This cell over here. And in that cell, forgive my crazy drawing, in that cell that is closest to 9 centimeters. So that would mean that the answer to the question of estimate the snowfall at point or rainfall at point A would be 9 centimeters. Okay, pretty straightforward. It's just literally just matching. Okay. My dog is on 1,000 right now. All right. So the next thing I'd like to do is to show you how to add a site. Okay. So let's just say I wanted to add this site right here. So the first thing that you want to do is just follow these steps right here. So find the site, the closest site. So the one that is closest to this blue dot that I just drew right now is this, the black site right here. So I'm going to draw a perpendicular bisector. To do that, I want to go right to the middle, right? And I want to draw a line that is perpendicular to these 2 points. So think of this like see an imaginary line between these 2 points. And I want to draw a line that is perpendicular. So it looks like it's going to go right there. Okay. Notice I stopped at the edge. Okay. When I got to the edge, because I don't want to keep going. The next thing that we're going to do is we're going to find the next closest site and we're going to repeat. So right now I found the perpendicular bisector that is between these 2 points. So the next site that I'll do is between these 2 points right here. So I'm going to go halfway between them, which looks like it's going to be right there. And I'm just going to eyeball what the line that's perpendicular to this is going to be. And it looks like it's going to be something like this, right? So again, I'm going to eyeball the perpendicular bisector, right? So I'm looking to make like 90 degrees with this line right there. So 90 degrees is going to look something like this, right? Remember, 90 degrees. So I'm going to, and I noticed that I stopped at this edge right here. So right now I found a perpendicular bisector. Let me just erase the stuff that's in the middle so I'm not confusing you, right? So right now I found the perpendicular bisector between that point and this point, and I found the perpendicular bisector between this point and this point. Now I'm going to do the same thing with the third site, right? Between this and this. So again, let me just go ahead and change the color so you can maybe see it a little bit differently, right? So here's the site, the new one that we're adding. Here's the one that is also closest. So I'm looking for a point that's in the middle. Notice that, again, I'm eyeballing this. So this line right here, the line that is perpendicular to it is going to form 90 degrees. So it looks like it's going to go something like that. Notice I'm going through that point. Okay. So what I'm going to do now is, right, the lines that are in black, the ones that were there, I'm going to now erase. So this one goes away, this one goes away, this one goes away. Let me just, for consistency's sake, go back and just draw this in blue. So that's going to be my new Voronoi diagram, right? Included with this site right here. And then I'm done, right? So erase any unnecessary lines. I'm just going to make sure that I write a note to erase these lines, right? So everything that's in orange or like yellow, I'm going to erase those. And the blue line is going to be my added Voronoi diagram lines. All right. So that's a medium-sized question that IB would ask you. And the last one is called the toxic waste dump problem. So what that basically means is, so like, let's just say these are like cities, okay, like capital cities. And so there is a toxic waste dump, right? Like a different point that we want to put. And we want to put this in a location that is the furthest away from each of the capital cities, right? So what we're going to do with that one is the goal is to find a location that's furthest away from any of the other towns. Another application of this is if you're a new store owner or a restaurant manager and you want to figure out where to put your store so that it's away from other competing stores, right? So like, let's just say these are like Targets or Walmarts, um, or Forever 21s, and you want to pick another store that is away from any of the others, so that way, like, you don't want it close to this one, because then you're going to be competing, right? So you want to put it in the spot that's farther away. All right, so where do we put this new, the circle that, or to figure out like where we should put the best location for a store that's away from other stores? So let's go ahead and take a look at this. So a pro tip is that point or that location where you should put it is going to usually be, well, I would say 100% of the time, is going to be on one of these vertices or a vertex, okay? So for example, if I were to take this point as a center and I have a circle that kind of looks like this, all right, not bad, Vergis, pretty good. If I have a circle that looks like this, right? if I'm trying to figure out what the radius is, this radius is pretty small, okay? So if this was a circle that I chose, this is a pretty small circle. So like, let's just say I don't want to choose that circle, right? Let's just say I want to look and see if I put this as my circle. So if I want to look at this radius right here, I notice that that is bigger, right? That is a better radius because it's larger. So now if I were to go ahead and draw my circle, kind of is going to look, that part is horrible, um, like that. Notice that the circle that I'm drawing right now, pretty horribly, but anyway, the circle that I'm drawing right now is going to have a larger radius than this smaller circle, right? This is a tiny circle compared to the one that I just drew. So if I wanted to find this radius right here, right, I could figure out the distance formula, right? Distance is equal to the square root, this is on your formula booklet, of x1 minus x2 squared plus y1 minus y2 squared. And then you could just go ahead and apply that formula to figure out what that distance is, to figure out what this radius is, okay? So we'll go ahead and do an actual problem here. This is just as an example, right? Right? You're pointless. So we're going to go ahead and just do this problem. So for the following Voronoi, we want to open up a new shoe store. So each site is already an existing shoe store. So you have, right, a site over here, you have a site over here, you have another site over here, another site over here, right? So boom, boom, 2, right, 3. So we want to open up to figure out what is the coordinates of the best location for our new shoe store. All right, so to find the coordinates of the best location for the new shoe store, remember our pro tip, right? Our pro tip is that it's going to most likely be on a vertex. Okay, so there's 2 vertices here. So let's see which one makes the bigger circle. So if I have this point and this site, right, these are the different shoe stores right now, 2, 3, and 4. If I look at those sites right there, um, if I pick this vertex, this looks like it's going to be, if I count 1, 2, 3, our radius here is going to be 3. Radius is equal to 3. On a test, you could use your fingers if you can, right, to figure out how much that is. Or you could take a piece of paper and you could like mark, okay, from here to here, how big that is, um, and see. So this one right here, this one is also 3, right? This is also 3. So the radius of that circle is going to be 3, okay? That's if I chose, this vertex to draw my circle with. Let's just say I chose this vertex, right? And I look at the nearest sites. So this right here, oh, that looks like it's considerably more than 3, right? That radius is going to be more than 3. It's like 1, 2, 3, 4, 5, and 1 up, right? So that distance looks like it's going to be bigger. I could have chosen this point as well. I could have chosen this point. So let's see what that circle would look like, right? It's going to look something like, it's going to be bigger than having a radius of 3. Something like that, right? I'm going to leave this site out because it's not closest to this vertex, okay? So now, what is the coordinates of this site? This is 5, right, in x, and 5 in y. So this coordinate right here is going to be at 5, comma 5. Let's put parentheses around it, okay? So now let's answer the second part. So what is the distance from the store? So here's where the store is. Okay, store to the nearest shoe store. So again, you can use either this point, or this point to find your distance. So we know that the store right now is at 5, comma 5. So if I call this x1, y1, let's just go ahead and pick this one just because I keep referring to it. This one is at 10, comma 6, 10, comma 6. And we're going to use our distance formula, right? So distance is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. And again, you don't need to memorize this formula. It's on your reference sheet. So let's call this x2 and y2. So now all we're doing is plugging in square root of, right? So we're going to have subtract our two x's, so 10 minus 5 squared plus, over here I'm going to do subtract my two y's, so I'm going to do 6 minus 5, don't forget to square it, okay? 10 minus 5 is 5, squared is 25, right? So the distance is equal to the square root of 25 plus, you could just plug this whole thing into your calculator, 6 minus 1 is 1, squared is 1, so the distance is equal to the square root of 26, and it's telling us that it's in kilometers, so kilometers, okay? So that is going to be your distance from your store to the nearest shoe store, and you could leave that answer as is. It doesn't tell us what to do with it. All right, so examples of why you should care, right? City planning, where should I put a new hospital? Where should I put an emergency or urgent care, right? Toxic waste dump, we talked about that. It also applies to ecology, geography, economics, and computer science. Food deserts, this is also pretty cool, so I wanted to show you, hold on one second. I wanted to show you the jasondavies.com /maps Voronoi airports, right? So you can like literally see the whole world, and you could figure out where is the nearest airport, right? So if I hover over this point right here, this is like Voronoi diagrams, right? So you could figure out where are the nearest airports to you, depending on where it is that you're located, right? So each of these has an airport. And so everybody, let's just go ahead and pick this one, right? Everybody in this yellow region right here would fly out of this Praslin airport, okay? And again, depending on where you are in the world, right, there are airports that are closest to you. For convenience sake and everything else like that, right, you might pick one that's a little bit further. But this is one application of Voronoi diagrams. Again, we talked about food deserts, right? Figuring out which is the closest target to you, closest, you know, Chipotle, Forever 21, right? Anything like that. These are different ways that we can definitely apply Voronoi diagrams, right? So here's some examples of where they come in handy. There's also some artwork that you could take a look at that is centered or based around Voronoi diagrams, right? Some computer generated artwork you can kind of see, right? Maybe it can be like an NFT, but people go ahead and use Voronoi diagrams all the time. All right, hopefully, I know this is a little bit of a longer lesson, but I want to make sure that you really understand it. Thank you. Before I end, of course, I have to stop us. These are some other examples. You can go ahead and pause this video and read if you are interested in hearing more or learning more about Voronoi diagrams or maybe using it for your IA. They use it in aviation, right? Urban planning. We talked about that, and even in medicine, astrophysics. So to generate clear images, study growth pattern of forests, right? It can be used for pretty much anything. All right. Thank you.